In studying Ohm's law, we discover that when we generate a net charge between two surfaces, we can allow current to flow. That net charge essentially creates a potential energy that allows the electrons to be pushed from one side to the other through that conductor. That is referred to as electric potential. And it's important to note that potential really is a potential difference of the electrical circuit based on the net charge of those two electrodes, positive and negative. And because electric potential could not exist without a potential difference between those two, it is often just referred to as potential. But it's important to note that potential itself is not the energy. Once we introduce the electrons flowing through the wire, that's when it becomes potential energy. And so voltage is simply the potential energy per unit charge. This is measured in volts as described in Ohm's law, but has important implications for some of the other terms that we'll be discussing or have discussed here in electricity. First of all, is the fact that if I solve this for potential energy, then I have the voltage times Q. And that is relevant because the work done by the system becomes the stored energy within that system. And so now we can describe the work as a potential difference times a charge Q. And this is relevant because we've already studied that force times displacement is work in a much more mechanical sense rather than the electrical sense. And so we can kind of relate these two as being the applied potential across the system in order to generate the energy, the applied potential across the system in order to apply the energy. But if you recall, electric field is the force per unit charge within a system. And so if I introduce that E times Q is the force here, then I have a potential times Q equal to the electric field times Q times D. And obviously the charges will drop out. And so we can describe electric field as being a function of the potential over a distance. And this is a valuable relationship for charged particles in space, how they are relating to one another based on their net charge and the separation between the system. Additional note on potential is the idea that since we know that the work done in a period of time is a system's power, we can also rearrange here to allow the work, which we described as above, as being voltage times charge divided by time as being the power. And so here, Q in a period of time we know is current, and so this simplifies to say that the power of an electrical circuit is current times voltage. This is a measurement of the electrical energy as a rate passing through the particular circuit, right? And so we have potential energy being equal to the work above, and then we have the work in a period of time being the power measured in watts for this circuit.